Okay, welcome to Psych 200 Research Methods. Today we are going to be continuing with our chapter on experimental designs, where we compare between subject designs and within subjects designs. Okay, and we were talking about between subjects designs last time, and this is where we left off. We talked about what between subjects designs are and some of the strengths and weaknesses, and now we need to talk about some applications of these between subjects designs. Remember that between subjects designs are basically these experiments where you have different participants form the different conditions of an experiment. So there's different participants that make up the treatment group and different participants that make up the control group, different participants that make up the placebo group, if you have that many groups. Okay, but often we just have a treatment condition and a control condition. Okay, we have two groups. So one application of the between subjects design is you can do what's called a two-group mean difference. Okay, it's a single factor two-group design, or also called a two-group design. And all you're doing is basically comparing two groups. So it doesn't work if you have three groups. Okay, if you have placebo, control, and treatment group, it doesn't work. You need to have a treatment group and then one other group. It could be a control group or it could be a placebo group, but only two groups, right? So you can test the difference between these two groups. It's the simplest version of a between subjects experimental design. Okay, it involves comparing the means or the averages of two groups of participants, the treatment group, for instance, and the control group, for example. The researcher manipulates one independent variable, let's say alcohol, right? With two levels. One group gets, let's say, no alcohol, and the other group gets enough alcohol to get them drunk. So one gets alcohol, the other one does not. That's two groups. You can test the difference between them. You can then check the level, the average level of aggression, and basically compare the differences there. And the way to actually do this test, well, you do what's called an independent measures t-test, which I actually showed you guys how to do already when we talked about statistics. So with an independent measures t-test, right, it shows if there's a significant difference between the two means, if there's a significant difference between the two groups. So remember, you're going to have a bunch of scores and you're going to find averages. Okay, and this test compares the difference in those averages. So that's one application of the between subjects design. Now let's talk about the advantages of the two-group design. We talked about advantages of a between group design. Now, what about the two-group design? When you only compare two groups. Okay, primary advantage is simplicity, right? It's actually very simple. Okay, it provides the best opportunity to maximize the difference between the two treatment conditions. Okay, so it provides you the best opportunity, right, to see if there's a difference, let's say, between those that consume alcohol and those that did not, right? You just compare those two groups, for instance. So you can choose opposite extreme values, right, for the independent variable. One group receives alcohol and you make sure that they are drunk, basically, legally drunk. And the other group gets no alcohol. They're completely sober. Those are two extremes, okay? And you can compare groups like that to see if alcohol has an effect. So it's very simple. It's often used to see if something works, if it works at all. Primary disadvantage, well, it provides too little information. Because it's simple and only compares two groups, you don't have a lot of information. The researcher obtains only two real data points. You compare two averages, right? And it's limited to two groups. It doesn't tell you that much. It tells you that basically alcohol works, or that exercise works, or that this drug works, right? You can compare the treatment group with the control group, but it doesn't tell you much else. So that's a disadvantage. It's simple, right? But at the same time, of course, there's not a lot of information. So we can do more than that. We can compare means for more than two groups. We can do an experiment, a between subjects design, where we can compare more than two groups. We can compare 3 groups, 4 groups, 12 groups, right? Depending on how complicated you want to get the experiment to be. Let's start with something simpler, of course, first, right? Let's start with just comparing, just more than two groups. Let's say there's 4, you can compare 4 groups, for instance. So in order to compare more than two groups, like compare 3, 4, 5, whatever it is, if you have just one independent variable, let's say like alcohol, exercise, or whatever it is, you can do what's called a single factor multiple group design. Single factor means that there's only one independent variable. There are designs that have 2, 3 independent variables, more complicated experiments, but we'll talk about that when we talk about factorial designs. That'll be the last chapter we cover, okay? So single factor group, multiple group designs means that you have an experiment, a between subjects design that basically where you have one independent variable, you know, maybe like alcohol or something like that, and then you have more than 2 groups to compare. So you can compare a treatment group and a control group and a placebo group, for instance. That's 3 groups. So you need to do that's a single factor multiple group design. Another example would be, you know, that you can compare driving, for instance, while using a cell phone, while texting, and while not using a cell phone. That's also 3 groups. You can compare driving. There, the independent variable, I guess, would be, you know, distraction, right? Those that are distracted using a cell phone, and those that are distracted while texting, and then those that are not distracted, let's say, not using a cell phone. And you can compare how well they drive, those different groups. So in order to do that, the statistical method you need to use, it's called a single factor analysis of variance, right? That's called an ANOVA. ANOVA stands for analysis of variance, right? You need to use the independent measures version of the ANOVA, okay? So you can determine the differences between the groups, okay? And provide stronger evidence for real cause and effect, right? Than a 2-group design. It provides more information, okay? Caution, it is possible to have too many groups in the study, right? It's much easier to compare 2 groups, you know, in which you use an independent measures t-test than 5 groups, for instance. You can have 12 groups, you can have many groups, 24 groups, right? Depending how complicated the experiment is. You know, but it gives you more information, but it can get complicated. So here's the point, okay? If you're gonna do an experiment where you only have 1 independent variable and you're comparing more than 2 groups, you're comparing 3 or more, right? And you only have 1 independent variable, this is what you use, right? You use a single factor, it's a single factor multiple group design, and you use the single factor analysis of variance in ANOVA to analyze it. You guys won't actually have to do this. This is something you would do like in graduate school, but I want you to know about it. And here's another example for you guys, just a graph here. It says hypothetical data showing a relationship between activity level and drug use and drug dosage for different levels of drug dosage, okay? So you have, you know, mean activity level is just how active participants are on average. So depending on dosage, right? We have that's the group of people that I guess got 0 drug dose. They didn't get any of the drug. And then you have those that got, you know, 1 dose of the drug. And then you have those that had 2, you know, and then 3 and 4, right? And you can see how the activity of participants varies with the dosage. You can see how it goes up at first, right? After they've received more than, you know, after they receive at least 1 dose, it goes up, and then eventually it peaks and then it declines. After a while, the drug doesn't really have much an effect. It seems to basically be impairing activity. Just another example, okay? And again, you would use a single factor, you would do a single factor analysis of variance here, like we just talked about. What about when you're going to compare, you know, proportions for more than 2 groups? What about when you don't have averages? What do you do? So what if you have, like, let's say, dependent variables that are on the nominal scale or ordinal scale? Remember that, you know, a nominal scale, when you use a nominal scale, right, that means that you have a variable that is basically, that has categories. It has names, basically, like gender, you know, male, female, other, something like that, academic major, psychology, chemistry, physics, right? That kind of stuff. So nominal scales just have categories. And what if you have ordinal scales, birth order, you know, a high, medium, or low, you know, being the firstborn, secondborn, that kind of stuff, where again, you have categories, but they're in a certain order from, you know, least to most or something like that. Okay, what do you do when your dependent variable is not a number? You can't do a t-test, right? You can't really do an ANOVA, so what do you do? Okay, So you cannot use an ANOVA to compare these, right? You don't really have averages, okay? So the data instead consists of a simple frequency count of participants in each category. What you do have is you have, let's say, you do know how many you have of each gender, or how many you have of each academic major, or how many in high, medium, and low, how many are firstborn, secondborn, that kind of stuff. So you have a frequency count. You have a number that tells you how many there are in each, okay? And you cannot use an ANOVA for this to analyze it. You have to use what's called a chi-square test. Chi-square test of independence, right? That compares the proportions. It compares the frequencies among the different groups. Obviously, you guys are not going to have to do a chi-square, right? But you have to know that that's what you use. You use a chi-square when you have basically, when you don't have numbers, when you have categories, okay? And here's an example for you guys. So this is hypothetical data. Let's say, maybe not so hypothetical. So this is based on a real experiment, I believe. Here you have data for an experiment. Now let me explain this. So participants watched a film of a car accident, okay? And then they were asked some questions. They were asked, did you see any broken glass? Did you see any broken glass when the cars smashed into each other? That's the top row of data there. When they hit each other, when the cars, or actually, or they weren't asked about broken glass at all, but just, they were just asked about how fast well, here's the thing. Let me try to remember this correctly. So how fast did you see any broken glass when the cars smashed into each other, when they hit each other, and the control, how would the control be? Did you see any broken glass? I guess it wouldn't say smashed into or hit, okay? And you can see the percentages that when you basically ask the question, how fast were the cars going when they, did you see any broken glass when the cars smashed into each other? You can see that more people said yes, they saw broken glass, right? A lot of them still said no, but when that question is asked, did you see any broken glass when the cars hit each other? You can see that a smaller number of people said yes, and much more of them said no. And when you have the control group, when they were just asked, did you see any broken glass in the film, right? Their memory was tested later. In that case, there were only 6 that said yes and 44 that said no. So what a chi-square test does is it compares these proportions. Is having a ratio of 16 to 34, that's basically almost like 2 to 3, the ratio there, versus 7 to 43. That's like, like 1 in 6. And again, with 6 to 44, that's also close to 1 in 6. So you can see the proportion is different just by eyeballing it, right? The chi-square test would tell you if there's really a different, if the pattern of the scores is basically different in each group. That's what it tells you. It's comparing the proportions. And that's just an example of that. All right, let's keep going. Let's talk now about within subjects designs. Okay, so all that stuff we just talked about, that was all between subjects design, where you have different participants making up the different groups, making up the treatment group, the control group, the placebo group, for instance. Okay, what about if you have a within subjects design? What is a within subjects design? Well, I told you guys what it was already. If you remember, it's a design, an experimental design in which you have the same participants take part in every group. So you have the same participants in the treatment group, the same participants in the control group, same participants in the placebo group. They get to participate, basically as many times as there are conditions. So what are the general characteristics of a within subjects design? Just to remind you guys, so it uses a single group of individuals, okay, and tests or observes each individual in all the different treatments that are going to be compared. So the same group of individuals participates in every level of the independent variable. Every level, whether it's control, placebo, treatment, or whether it's low alcohol, medium alcohol, high alcohol, low exercise, medium exercise, high exercise, right? They basically participate in all levels. It's also called a repeated measures design because participants basically repeat their participation. They participate more than once. The study repeats measurements on the same individual under different conditions. That's why it's called the repeated measures design. Let's keep going and say a little bit more about this. Well, actually, here's an image for you guys to help you understand. And I showed you guys this before, when we were trying to differentiate between subjects design and within subjects design. Here it is again, for those of you who are more visual. So you have a sample of participants that are going to be in your experiment. And those group of people, let's say there's about, how many there? There's 4, 8, there's 5. There seems to be about 13 of them. Okay, but anyway, this sample of participants, right? They all participate in treatment 1. Maybe that's the group that receives alcohol. And then they participate in treatment 2, the group, let's say, that receives no alcohol. Of course, they would be on a different day, okay, when they're already, when they've sobered up. And then they would also participate in treatment condition 3, which might be, let's say, the placebo, of course, on a different day. So the same participants participate 3 different times in all the treatment conditions, okay? So here's the thing, they don't necessarily participate in the same order, however, okay? And I'll explain that in a moment, okay? It's something called counterbalancing, okay? Some might participate in, the first treatment at first, and some might start with treatment 3, some might start with treatment 2. You can counterbalance, and we'll talk about that later. So that's a within subjects design. Now, what are the threats to internal validity with a within subjects design? Remember, internal validity has to do with cause and effect, okay? So what are some problems that you can have with the within subjects design, okay? Well, you can have confounding from environmental differences, okay? There's potential confounds. So those confounds can be due to environmental differences. So the characteristics of the environment may change from one treatment condition to another. So let's say the participant comes in and participates in, let's say, treatment group 1, okay? And that's the treatment group that, treatment group that receives alcohol. So they participate in that. And then let's say some days later, the same participant comes in again and participates in treatment 2, right? And let's say that is the placebo group, not real alcohol. But let's say on that day, let's say that there's a lot of noise outside, construction going on or something like that. So it's kind of a bit annoying, it's noisy, and that's going to change, how they may feel, how they may behave. Okay, that's just an example of how environmental differences can affect these participants because they participate in the different groups at different times, and the environment may change during that time. There's also time-related variables, confounding from time-related variables. So these are confounds that have to do with time. So between the first measurement, let's say, and the final measurement, because remember, they participate more than once, right? The participant may be influenced by factors other than the treatments. Okay, and here are some examples of those factors. Some time-related threats, right? So history, history can be a problem. Maturation, instrumentation, regression toward the mean, order effects. These are all things that are related to time, right? So things can change for participants, right? The history can change. Things can happen while they're, one treatment versus another, and that can change them. There's also maturation. Maturation is basically just the participants maturing over time. People change over time on their own. People sometimes become, more responsible. Sometimes they become more knowledgeable, or, that usually doesn't happen over a short period of time, but it does happen. You can have instrument issues in one condition, but not in another, right? At a later time, let's say there's instrument issues where there wasn't the first time that you ran them through the experiment. Regression toward the mean is a little bit harder to explain, but regression toward the mean is basically when you may have extreme scores. Let's say the first time the participants participate, but it just, it's not typical. You had an extreme score. Let's say they scored really high for some reason. And then the second time, they're more normal. So the score goes more toward the average. It comes down or something. Or maybe it goes up because they scored really low the first time and then they score more like the average second time. That's just called regression toward the mean. That's something that has to do with statistics. It's a little bit harder to explain, but it happens when you get extreme scores. Okay. There's also order effects. Order effects is a big problem. Okay. Participants, they participate, once, twice, 3 times because they go through all the groups, all the conditions, and you have practice effects. They've seen the experiment more than once, so they may behave differently the second time, the third time. You have fatigue. They may be tired of it or bored by it, and because of that, they may behave differently. You have carryover effects where they were affected by the first time they were in the experiment, right? Let's say you pissed them off, you got them drunk and you want them to behave aggressively, so you pissed them off. And so the second time they come into the experiment, right? Let's say they're still a little bit annoyed about the first time they went through it and they didn't like what you did to them because, well, you're studying, let's say, the effect of alcohol on aggression. So you did something to bring out their aggression. So they come to the experiment the second time, now they participate in the control group, let's say, and well, they're still a little bit pissed off and behave differently. These are just some examples of time-related threats. There are ways to limit these problems, ways to limit these threats to internal validity and within subjects design. You can minimize history and maturation effects by just shortening the time between treatments. Okay. So history are just, things that can change, through time, right? Just like somebody who's growing up, like say 20 years ago would experience different things than someone who's growing up today. Okay. That's history. Okay. Well, if there's not a lot of time between, let's say, the time in which the participant participated in the treatment group and in the control group, if there's not a lot of time, there isn't really much time for history to take place. There isn't much time for life to really change. Okay. So you can, minimize that threat in that way. And if there isn't a lot of time also between treatments, participants aren't really going to mature from, let's say, 1 week to the next. Okay. There isn't much time between treatments or 1 day to the next, right? You can minimize those problems. But when you shorten the time between treatments, that increases problems with order effects. So remember, participants can participate in the treatment group, the placebo group, the control group, let's say, right? And if there's only a short period of time between the treatments, there could be effects left over from the first time they participated. So let's say you were mean to them because you wanted to bring out their aggression, right? When you ran them through the experiment the first time, okay? And then here they are again in your experiment a day later, and they're still mad at you because you were mean to them. It's part of the experiment, but they didn't really, they don't really know that, okay? But they're still a little bit pissed off. So that's basically causing problems now in the other condition. Okay, so that's gonna be a threat to internal validity. That's gonna affect your ability to make a cause and effect conclusion. Okay, because you want the treatments to be different, right? But if the effect of one is left over and carries into the other, and that's what that can happen when you minimize the time between treatments, well, then you can mess up the experiment. There's a way to deal with, also with these threats to internal validity. Another one called counterbalancing. Counterbalancing is basically when you balance, the order in which participants go through the treatments. Okay, counterbalancing. So you can have some participants start with treatment 1, do treatment, then 2, right? And some can start with treatment 2 and then do number 1, right? Or if there's treatments 1, 2, and 3, one can start with 1, then go to 2, go to 3. Another one can start with 2, go to 3, and then 1. Another one can start with 3 and then go to 1, go to 2. And you can have different orders. You can counterbalance the treatments, okay, to deal with some of these problems. That reduces problems with practice, basically practice effects, because participants go through the experiment several times. And if they always go through it in the same order, then you have, the same practice effects in the same order. So if you mix up the order, it deals with that problem, okay? It also deals with the problem of fatigue, because if participants always go through the experiment in the same order, the groups in the same order, then the one that's last is the one that's going to suffer most from fatigue. But if you start them in different order, then you kind of you minimize that problem, because fatigue isn't always gonna, if fatigue is a factor, it's gonna affect the groups equally. So it's not gonna really cause any differences. You're gonna also reduce the effects of carryover effects, right? If you run the participants in different order. All right, let's keep going. So let's compare these within subjects and between subjects design, okay? The differences. Okay, so advantages of within subjects designs. Okay, we just talked about that. So one very big advantage of within subjects design, when you have the same participants participate in the treatment group, the control group, the placebo group, is that you require less participants. So let's say you need 20 participants, per group, right? You have 3 groups, let's say, okay? Within subjects design, you would only need 20 because you have the same 20 in the treatment group, in the control group, and the placebo group, okay? It also eliminates problems based on individual differences. Because you have the same participants in each group, there's no individual differences. The groups are always the same as far as, the participants. So the participants can't be relatively smarter in one group than another, or older, or anything. They're the same people. And that will also reduce variance. It increases the chances of detecting a treatment effect because your participants are the same in each group. So you're minimizing the difference within the groups, which is a good thing. There's not a lot of variation within the groups. So what's going to cause a difference? You're hoping that's going to be your independent variable. And that will cause differences between the groups, okay? So those are good things about within subjects designs. More about within subjects design. With a within subjects design, also there are no individual differences between groups. There's only one group of participants. I kind of already told you that, okay? You have the same participants in each group, so they can't really vary. They can't differ because it's the same people. The group in one treatment is exactly the same as the group in every other treatment, okay? So they're the same. The result is that there are no individual differences between groups to confound the study. There's no confounding from individual differences. Each subject appears in every treatment condition. Each subject serves as their own control. There are no differences, okay, between participants. They participate in every group. Okay, and I told you guys that already. In the previous slide, I explained what this slide is doing. Let's keep going. Disadvantages within subjects design. What's the bad thing about within subjects design? Okay, there is no study that is perfect. Okay, they all have flaws and strengths. Okay, they all have strengths and weaknesses. Nothing is perfect. Okay, so here's the thing. Here's one problem. Okay, each participant usually goes through a series of treatment conditions, one within each treatment administered at a different time. Okay. So each participant goes through a series of treatment conditions, treatment condition 1, 2, and 3, right? And this is at different times. This can lead to time-related factors, right, that influence the subject scores. And I actually talked about these already. Okay, I mentioned the time-related factors when I talked about the threats to internal validity. So remember how things can happen between the time that they go through treatment 1 and treatment 2. Things can change, and that can change the way participants behave, right? Those are time-related factors. One I haven't mentioned is participant attrition. Some of the subjects who start the study will drop out before the study is completed. That always happens. You have participants, right? And they're not always as reliable, as conscientious as you want them to be. So they agree to participate in the study, and they don't make it all the way through the study. They go through treatment condition 1, treatment condition 2, and they don't come back for the third one. Why? Because they're irresponsible, they're lazy, they don't answer their call, their phone, they don't answer their email, whatever it is. That's what happens. Just like I have students who don't do work at the right time, right? Or they, or they don't get the work done, or they forgot about this or that. Same thing happens with these participants. They don't behave perfectly, right? The way you'd always like to do. Some of them start the study, and then somewhere between, the beginning and the end, they drop out, or they forget, or for whatever it is. That's called attrition. They don't finish the study. And that's gonna basically lead to, that will lead to you having a different number of participants in different groups. So you start out, let's say, with all your participants in treatment 1, and then in treatment, by the time you get to treatment 2, right, there's less now. And then treatment 3, there's even less. That can happen. here's the thing, so that you don't end up with different number of participants in each group, you should always counterbalance, run the participants in different order. So you're going to have some drop out here and there, but your number should be similar if you counterbalance, if they don't all go through the experiment in the same order. Okay, that is where I'll stop. So I'm going to stop recording.